Welcome to section 5.1, video 2. This will be the video regarding terminal points. First, let's start with a definition. So when we're talking about terminal points, we're talking about if we're on the unit circle and we move around the unit circle and we end up at some point. How do we figure out what that value is? So we have the following. First, suppose t is a real number. So t is our terminal point. We're moving a distance t around the circle, and we want to know what is that terminal point. So we're going to start at 1, 0. So on our unit circle, the value out to the right on the x-axis, 0 radian measures, or 0 degrees. So we have 3a and 3b. First of all, we're going to move counterclockwise if t is greater than 0. So if our value is positive, we're going to move counterclockwise around the unit circle. 3b says that we're going to move clockwise if t is less than 0. So this is important. When we're discussing terminal points, we're trying to find the radian measure for a terminal point. If t is positive, we have to move counterclockwise. If t is negative, we're going to move clockwise around the unit circle. And then 4, once we move that distance, we arrive at the point P, which has values x and y, called the terminal point. So if we're given some radian measure, we just got done talking about the unit circle in part 1 of the video series for section 5.1. So if we're given a radian measure and we want to know what its terminal point is, we want to know what are the coordinates at that point, this is how we determine that value. So I'll pause for a minute before I erase so you guys can get these notes down. We'll do a couple examples here. Again, if I start to erase something, of course, you can always just pause the video before I get done doing that. You can always go back if you missed something, go back if something isn't quite clear. Any questions you do have, make sure that you write them down, jot them down in your notes, so when you come to class the following day or a couple days later, you're able to ask those questions at that point if something's a little bit confusing. So let's look at an example. We want to find the terminal points so the first value is pi. So I'm just going to draw a little unit circle over here on the right. Remember, this is 0. Pi is over here. At the top is pi over 2. The bottom is 3 pi over 2. So if I want to know the terminal point for pi, well, what were the directions that we follow? We're going to start at 1, 0, or our value for 0. We're going to move, because this is positive, we're moving counterclockwise. So we're moving counterclockwise around the circle a distance of pi, and we end up here. So we want to know, what are the coordinates at that point? Well, the coordinates are -1 and 0. What if I have 3 pi? Couple ways we can do this. We know that entire time around the circle is 2 pi. Or we know that every time we go halfway around, it's a distance of pi. So if I start at 0, because this is positive, I'm moving counterclockwise again. So I move a distance of 1 pi, 2 pi, 3 pi. So 3 pi is actually the same as what? This is the same as just pi, which we just figured out, which is -1, 0. So pi, 3 pi, 5 pi, 7 pi, they all have the same terminal point, which is -1 and 0. What if I have negative pi? So now we have to be careful. We have this negative sign here, so we know from our 3b, if this value is negative, we're going to move clockwise around the unit circle, but the distance we're traveling is still pi. So if I start at 0 and I move the distance of pi around the circle, well, what happens? It still puts me back at positive pi, which we know again is -1, 0. So what happened here? Pi, 3 pi, negative pi, they all have the same values for their terminal point, which is -1, 0. So we can describe points on the unit circle in a variety of ways, but it still gives us the same terminal points. And that's important. We're going to deal with that a lot throughout the semester. Depending which way you're moving around the unit circle, it could still give you the same value as other measurements. And lastly, what if I have t, our terminal point, is equal to -pi/2? And these all probably should have said t is equal to, because those are our terminal point values. Terminal point. So t is -pi/2. So minus tells us what? Minus tells us we're going clockwise around the circle. Pi/2 tells us what? Well, that's 1/4 of the way around the circle. So if it was just pi/2, we start at 0, we go to pi/2. No big deal. But here, because it's -pi/2, we're starting at 0, as we always do, but now we're moving clockwise a distance of pi/2, which puts us there. And that value is equal to what? That value is 0, -1. So 3 pi/2 also has the value 0, -1. So -pi/2 is the same thing as saying 3 pi/2. Again, we can describe it in multiple ways. All right, so let's do a few examples here. I'll give you guys the examples. And then what I would suggest is as you work it out, just hit pause on your video player. Then when you're ready, when you think you have the answer, if you get stuck, hit play again, and I'll work the problem out from that point. So we want to find the terminal points for the following. The first one is t is equal to -pi/4. So go ahead, hit pause. Try to work this out. Once you're ready, come on back and I'll work it out. All right, so t is -pi/4. So if I have my unit circle, I'm starting at 0, as I always do. Because of the negative, I'm going clockwise, and the distance I'm going is pi/4. So the distance I'm going is only 1/4. Our regular pi/4 is up here in quadrant 1. But because I'm coming negative, it puts me down at this point here, which is the same as what? it's our value for 7 pi over 4. So if you go to your little diagram we filled out in video 1, or if you just know that pi over 4 has the values of square root of 2 over 2, square root of 2 over 2. Remember I told you in video 1, you're going to want to know these things. I promise you by the end of the semester it'll just be second nature. But the sooner you can kind of commit these to memory, the easier it's going to be. Because we're down in quadrant 4, these x is positive, y is negative. So t is equal to minus pi over 4. Our terminal point then would be square root of 2 over 2 and minus square root of 2 over 2. All right, second example. T is equal to 3 pi over 4. So again, hit pause, give this one a shot, come on back when you think you have it. All right, did you get it? I hope so. So 3 pi over 4 is what? It's positive, so we're going to move counterclockwise. We have 1/4, 2/4, 3/4. So if we had our unit circle, it's putting us here in quadrant 2 at that point. Again, when 4 is in our denominator, we know it's square root of 2 over 2, square root of 2 over 2. But in quadrant 2, x is negative, y is positive. So it's negative square root of 2 over 2 and positive square root of 2 over 2. And our third example. Our third example is t is equal to minus 5 pi over 6. A little trickier this time. Again, pause, give it a shot if you get stuck, if you can't figure it out, if you want to check if you're right, hit play and we'll see what happens. Okay, so minus 5 pi over 6. So the negative tells us we're going clockwise around the circle. The 5 pi over 6, if it was just 5 pi over 6, if we look at our little sheet, we know that's what? We know that that would be over in that zone there. But because it's negative, we have to go the same distance but the other way. So it actually puts us over at this point on the unit circle right there in quadrant 3. Again, because of the 6 in the denominator, we know that those values are going to be square root of 3 over 2 and a half. And because we're in quadrant 3, it's going to be negative and negative. So negative 5 pi over 6 has the terminal point values of negative square root of 3 over 2 and negative 1/2. Hopefully you were able to figure that. That ends part 2 of the video series for section 5.1. I'll see you again in part 3.